Differential geometry. Now we're looking at our curvilinear coordinate system, which has unit vectors q1 hat, q2 hat, and q3 hat, and our origin is at the position q1, q2, q3, given by the coordinates q1, q2, q3. So our starting point for this differential geometry is the origin, which it has the coordinates q1, q2, and q3. Now what we do is on the coordinate axes q1, q2, q3, where we have the unit vectors q1 hat, q2 hat, and q3 hat, we're going to change the coordinates by an amount dq1. So we're going to change coordinates for q1 by dq1, q2 by dq2, and q3 by dq3. Now, when I change the coordinates by that amount, because I have the scale factors, which is the derivative of position vector with respect to qi, that multiplied with dq gives me the differential displacement in that direction. So for each of these, I have these edge lengths for these differential displacements. So for dr values on these edges, I have to multiply the scale factor with the amount of change in the differential change in the coordinate axis, dq1. So for each edge length, I'm going to have hi dqi. So these are the edge lengths. And when I go from qi to qi, for example, I'm going from q1, q2, q3 to q1, q2, let's see here. I'm going from q1, q2, q3 to q1, q2, q3 plus dq3, for example, here. And here I have, so I'm changing these coordinates by an amount here, for example, going from q3 to q3 plus dq3. Here I'm going from q1 to q1 plus dq1, etc. And here I'm going from q2 to q2 plus dq2. These are the new positions. The scale factors are all evaluated at the origin here, so which is at q1, q2, q3. So all displacements starting from this point, I have to evaluate the scale factors at the origin. So at the individual qi values. So hi's will be evaluated at qi. So when I go from qi to qi plus dqi, hi's are evaluated at qi. But if I'm going from qi plus dqi to qi plus dqi, for example, I'm going from q1, q2, q3 plus dq3 to this point here where I also have q3 plus dq3. So it is it's going to be q2 plus dq2, q3 plus dq3, and q1, for example, if I go here. Now, because I'm changing so my original point is here, I'm changing from q3 plus dq3 to q3 plus dq3 on this edge. I have to evaluate the hi value at that point. So it's going to be hi evaluated at qi plus dqi if it is going from qi plus dqi to qi plus dqi. So hi should be evaluated at qi plus dqi. Okay, so let's read the edge lengths here. So when I start from this position for all of these, I have to evaluate the scale factors at the original position. But when I reach another point here and I'm going from that point to a different point which does not include the origin, then I have to evaluate the scale factors for that position. So here I'm at the coordinate q3 plus dq3. So that means my scale factor h1 should be evaluated at q1, q2, q3 plus dq3. So likewise here. So you have to consider the smallest value of these coordinates to find the correct scale factors. Okay, so for the differential geometry here, each edge length with differential displacement dr is given by the scale factor, which is del r del qi multiplied by dqi, and the evaluation of the scale factor has to be considered to be at the lowest possible set of coordinates that we have to consider. Now, what is the differential volume of this region? So I have edge lengths h1 dq1, h2 dq2, h3 dq3. So basically, I have to multiply these edge lengths to get the volume. So this is basically considered to be a cube with those edge lengths. So my approximate differential volume will be then d tau is equal to dq1, dq2, dq3 multiplied by h1, h2, h3, and the scale factors are to be calculated at the position q1, q2, q3. So that's how I calculate the differential volume that's defined by these edge lengths. Now let's consider the bottom surface area. So for the bottom, I have h1 dq1, h2 dq2, so that those two should be evaluated at the origin as well. But if you look at q1 hat cross with q2 hat, that's going to give you, with the right-hand rule, a vector that's pointing inwards, but we want the area vector to be always pointing in the outward direction. So I'm going to include a minus sign. So it's going to be in minus q3 hat direction, not in plus q3 hat direction. So bottom surface area vector will be then d sigma bottom can be written as minus dq1, dq2, h1, h2, q3 hat. So it's in minus q3 hat direction. Once again, the scale factors are evaluated at the position q1, q2, q3. So that's how I write the bottom surface area vector. And the minus sign is to have the normal vector pointing out of the volume. Now, likewise, we can work on the top surface area. Here I have, for the top surface, because I'm at position q3 plus dq3 instead of q3, the scale factors should be evaluated at q1, q2, and q3 plus dq3. And other than that, the cross product of q1 cross q2 gives me q3 hat, which is basically normal to the surface pointing outside. So there I don't need a minus sign. So for the differential area vector here for the top, the sigma top vector is equal to dq1, dq2, h1, h2, q3 hat, and the scale factors are evaluated at q1, q2, because we're on top right now. This is at q3 plus dq3. So that's what I have to pay attention to, because it's the top surface that I'm concerned with. Okay, so we talked about the differential geometry, where we have the curvilinear coordinate axes q1, q2, q3, the corresponding unit vectors here. For a differential displacement on each of these axes, I have to multiply the differential change in the coordinate with the scaling factor, and where I have to be careful about which surface we have these vectors. So for the uh, coordinates here, q1, q2, q3, all of these edge lengths are calculated using the smallest possible list of values. But if I go to the top surface, because now I'm at q3 plus dq3, but for both of these points, so that means the scale factor should be evaluated at that point. Differential volume is h1 dq1, h2 dq2, h3 dq3. So this is approximately a cube. And for the differential area, I have h1 dq1, h2 dq2, but the vector should be pointing outside in minus q3 hat direction, and the scale factors are evaluated at q1, q2, q3. For the top surface, I have h1 dq1, h2 dq2 area, but the scale factors are evaluated at q1, q2, q3 plus 2q3, and the vector has to be pointing normal to the surface. It's in q3 hat direction, so I don't need the minus sign.